few things that we want to go over today. We're going to do some grinding here in a little bit. But first I just want to make an announcement that Justin with Good of the Land will be hosting a YouTube, I guess, meet and greet type thing, a little event that will be taking place the weekend before Thanksgiving here in November. So we plan on going. We're hoping things work out, and so as it is now, nothing is hindering. Hope to meet a lot of you there. We just got back from Illinois, where we had Mr. Pete meet and greet. Had a great time. Met a lot of people, a lot of the subscribers, and for me that's really the highlight of those events, being able just to put a face to all the different names on the comment sections we get and whatnot. But anyways, we got a lot going on. A lot of the videos that we have made, you've seen this block right here. And a good friend of mine, Daryl Smith, he calls these squaring blocks. And I thought, yeah, that's a pretty good name for them. So that's what I'm going to call them from now on, a squaring block. I mentioned before that if there's any one tool that I would be limited to in grinding, this would be the tool I would choose, because I use it all the time. It is just so key to squaring blocks or your other work up. And so anyways, we had interest from some people that they wanted to buy some of these, and they're not going to be cheap. It's not because they're extremely difficult. You just got, I believe there's over 100 tap holes in the front. We got tap holes in the side. They take time, and to grind to the precision, in about 4 inches, I know this block right here checks out to within about 50 millionths of an inch. So very precision. But we had some people asking if we would be building these, and so we bought enough material to make 3 of these. I had one already that a guy agreed to buy out of Norway, and so anyhow I thought, well, we're trying to keep the cost down, and I'll just buy material to make 3 of these. All 3 of them are spoken for right now. If there's any interest, we can make some more in the near future. I'm shooting the target price I'm going to shoot for is $1,200, and again, there just takes a lot of time to get the grinding that good, putting all the holes in. The material itself, if you just bought one piece of material, did all the heat treat, and have a normalization process done, you're talking about almost $400 just for the material and the heat treat if you were just doing one. So that's one reason why I like to buy them, in this case, in at least 3 at a time, because then I can share the heat treat costs, the minimum charges. The steel gets cheaper the more you buy, and so that way I can try to reduce the price on them. But anyways, we'll be making some future YouTube videos with these blocks. We're not going to be doing it today. We got something else that's different. I'm going to just set this aside a minute. What we're going to do today, we're going to finish up making an attachment that I'm going to need for grinding these 3/16 pins. I had a customer with a job a month or 2 ago. He wanted me to use this spin fixture over here, and he wanted me to grind the diameters down on some 3/16 pins, and he wanted me to grind the diameters down. I think the lowest diameter went with 150 thousandths, and it was about 1.8 inches long. Well, anybody that's done any grinding, you'll know that that's quite difficult to grind something like that. And I have a unit where I can stabilize the end of the pin so it's not moving around, but I wanted to try to get away from having to use that. And as many of you have who've talked to me in person at some of these events, as well as some of the YouTubes I mentioned, my experience in grinding, in my opinion, probably the 2 biggest things you want to focus on for success in grinding is wheel selection and the dressing and truing of your wheel. All those other factors, there's many others, they're important too, but I think these are the 2 biggest ones that I focus on. So in the past, we focused on the 46 grit wheel for just general grinding, squaring up, using a porous wheel, using ruby content. Well, here we're going to go to the opposite end of the spectrum, well, maybe not the opposite, but a different spectrum. We're going to use this Radiac wheel. It's an RA, it's 100 grit, it's a hard bonding, it's L5 and V8, so it's not a open structure, it's closed. One of the reasons why I want to go with ruby, talking to one of the guys at Radiac, they said that the ruby had very sharp grain structure on there, and that was one of the reasons ruby cut so well. But anyhow, I used this wheel. I dressed it on the end of here. What I would do is I would dress it and I would relieve it for about half of it. It's a 1/4 inch wheel, so I would only have a cutting surface of about 1/8 of an inch, and it just blew my mind at how well it handled grinding these pins with no support on there. So what I thought I would do, just out of my own curiosity, I thought I would set up and try to modify my setup a little bit. Try to make things a little bit different, see how much I can get away with. And in fact, before I get there, I'll show you how I ground those other pins. I have a little V and I have a notch in the bottom over here. So if you put square things in here, this is clearance so that you're not held up on a radius at this point. If you're putting round things though, like small pins, one of the problems with the V down in here is that the tangent point is down in this, it's just a mill or saw cut. In this case I think it's a mill cut. And it's really not holding tangent with the V's. So I had one of these little V's. Let's see, I'm just guessing around 1/2 inch wide. I could stick this in here. I can stick the V in there, or yeah, the little V block. And I can push this up to the end, and because there's no cutout in the bottom, now I'm touching, I have a 3-point contact. Let me grab my pointer here a minute. And that's what I want, is this 3-point contact. I got one contact on this side that's tangent to that 45 on this V, and then the pin, I got the tangent point where the pin is tangent to the 45 degree on this side, and then the third point will be the pressure that you have on the screw. Well, what happens when you tighten the screw up, you can put pressure in there and that metal will move. You can throw an indicator on there and you can actually, when you're tramming this in, it's by the position of the screw, where you at on the V-block, the amount of pressure you have on there, you can true these things up really nice. Trouble is, with something this small, and it did work out good for the project I had, I have very little contact surface, just the thickness here, where that pin lines up tangent. So what I did in the meantime, I made a bigger V-block, and that will go back just about all the way. So now when I stick my pin in there, I got support this entire length right now. And so you can see it's support in that length rather than support in that length. And so I think that will help out with the rigidity. But I still have an issue if I put the pin in. Even though I have this greater length now, the third point of contact is just the size of this screw. And again, by positioning this clamp different places, I can get different reactions out of that pin there. So one of the things that I want to do, I want to make a little hardened part of steel that will go on the top of here, and it will spread the force out. Robin Renzini did this on, I think it's his second to his last video he had, I think it's some grinding tips #1 if I remember right. And he would put a block, a square block in there, and that way when you put the screw pressure in, that pressure evens out a little bit. What I'm going to do something a little bit different. I'm going to make a block like that, and then I'm going to relieve, and this is a block I'm going to use, I'm going to relieve the center section so that I have a contact point here and a contact point here when I screw down. And so I'll have a 3-point contact in the front, I'll have a 3-point contact in the back, and I can still have some adjustability in that pin as I move this clamp back and forth. So now I'm going to have, hopefully, an ideal holding solution, 3-point contact in front, 3 contact in back. So anyhow, this will probably be a 2-part video because we're going to go over some things. One of the things that I want to show, I've done this on my Instagram, is this is just a piece of hardened steel. I don't even know what kind of steel it is. It was just some scrap stuff I had laying around. This section's about the right size I need. So I just want to cut this off. And I need to cut this off, and I want to do it kind of in a fast manner without spending a lot of time. So if you've been following our Instagram, you've seen that I've used these cutoff wheels. They make them for the surface grinders. This one here, I believe, is an 8-inch one, 1.25-inch hole. But if you mount these on the surface grinder, I can take this and I can slice that off. It slices real fast if you do everything right. This is about 46 thousandths thick. It's very thin. This is a non-reinforced cutoff wheel, so it breaks very easy, so you got to be very careful. I already have one mounted on the surface grinder, but when you have these, you can see they don't have the little paper washers. And you can get from your grind supply house, they'll have these, you can get them, but you're going to want to make sure that you have these washers on both sides. And what will happen is if this wheel would stop, and it'd pinch apart, and your arbor is spinning, all this grit right here would start acting and it would grind on there and you would ruin your arbor. By putting these papers here, you can help absorb some of the pressure from your clamping when you're tightening up your hub, as well as if this thing would spin and then it's spinning on the paper, there's no abrasive that is working on your hub. So what we're going to do now, we're going to go over to the surface grinder. We're going to go ahead and we're going to slice this all off and show you how nice these wheels work. And one of the things that when you use these cutoff wheels is they throw a lot of particles in the air. And I don't like breathing this stuff, so I'm going to wear this respirator. And if you have some kind of dust collecting situation set up, you can use that, but we don't have that, so if I do something like this where I know there can be a lot of particles, this is what I'll use. Now when I have it on, you're not going to hear me talk very well, but basically I took and I touched off on the side of the wheel, I set my digital 0, I'll wind over now, 46 thousandths roughly, 48, and then what I'm going to do is I'm going to touch off on the top as well. And what I'm going to do is I'm going to wind over, I'll make that roughly 3/8 of an inch thick, somewhere in that area. I'll go a little bit more so I can grind it. So right now I'm just wanting to come across the top and touch at the top. I'll set my digital on the Z, and I'm going to cut this all in one shot. So that's about 450. I'm going to wind down because these wheels will break away. I'm going to wind down about 700 thousandths. And I'm going to put this mask on and we'll cut through, and hopefully Adam will get some nice close-ups and you can see how nice this cuts and how free it cuts. And again, if your setup is good, it'll cut real good. But you got to keep in mind, a non-reinforced wheel is very brittle. They're very easy to break. there you have it. Just one cut that quick, and the part is off. What we'll do now is we'll just go offline. I'm going to get set up. I'm just going to square this part up. When we come back, I'll have it finished up. Well, we're back, and I just want to show you the block that we just finished grinding. And it was a rough grind. I did it real quick. I was in a hurry. It doesn't have to be real precision. It doesn't have to be real square. It doesn't even have to be real flat. But I just want to show you how awesome that this Acer grinder is. I love this thing. Like I say, it does a super good job. I've ground on so many different surface grinders, but I tell you what, if for a brand new surface grinder, the price is really good for people that are just wanting to get into the business, just starting, don't have a lot of money. It sounds like a tractor just went by. But anyways, just to show you the quality that they have. I have this amp set from 0 to all the way over here is 1,000. And so each of these lines represents a 50 millionths. And keep in mind, I wasn't even trying for flatness, squareness, taking a lot of time. It's just the way I got everything set up and dialed in, and the quality of that machine. So I'll just, let me move this around so you can see it a little bit better. And again, each of those little marks is 50 millionths. So you can see that the thing is just a super grinder. Works real nice. One thing that we want to do now, we're almost done with it, but I thought it'd be kind of neat just to show you. I don't know if Adam can get in here and get kind of a close-up. These V-blocks that we make. Let me grab another one here too. Anytime I make V-blocks anymore, I put holes, counterbore holes in here so I can bolt these up to, say, a block like this. I can bolt them up. That way I can actually make a nice gooseneck type V-block. I can bolt them up like this. I can bolt them up this way. So I can bolt them up to any other blocks and tools. I also, on this one as well as this, I like to put tap toes in the face of the V. And the reason I do that is because if your V is ground real good and square, parallel, flat, I should have a 45 degree here and a 45 degree here, very precision. And I know this is precision. And by having the tap toes in here, if I want to just bust some 45s on here, some real nice accurate 45s, although I don't need it for this block, I just need it just to take some sharp edges off. I can take one of these finger clamps right here. I can pop that in there. I got some gauge block stack set up underneath, and so that I can just Pop them on like so. Snug them down. And now I can surface grind and pop some 45s, and I'm going to do that all the way around, and we'll cut over here, we'll get the generator turned on, and we'll come back and we'll cut some 45s, and then we're going to cut a step in here, and then we're going to have a block that we can use a couple different ways. I just wanted to mention too that these precision V blocks made like this, this is something that we intend to make on a future product. Not nothing real soon. We got too many irons in the fire right now, but somewhere down the line we'll plan on making these and offering them as well. So what's nice about this, you can do some very precision work, and you can bust a nice 45 on there. You can control the depth, do the math, work it all out just exactly how you want it. Here I don't have any size I'm going to, I just want to make a nice edge on there. Nice break on these two sides, and I'll have a lesser break on the other side. I went 30,000 straight down. What I'm going to do, there may be a slight burr on the edge, so I'm going to take one of these stones that made when I guess I'll call them the Robin Renzenni stones, and then we'll take and knock any edge off of there. This side I'm just going to break the edge by about 5 thou. On this side of it, we have about 30 thou on the other side. Again, nothing real precision, although I could do real precision work with this setup. Here I just want to break these sharp edges. What I'll do is I'll set this down on the granite table. We'll let Adam get some close-ups to show you. Actually, I'll turn it over so we got the bigger 45 here. We just got a 5 thousandths 45 on this side, about 30 on that side. And we're almost done with this block. One more step to go. What I'm going to do, I'm going to cut some relief in this block right now, probably in this kind of area right in here. And I'm going to cut that probably about 10 thousandths deep. It's all relief. I could tell when I touched off on there that by putting the 45 and bumping them in there, that this wheel loosened up just a little bit, and it was moving on me, and I could tell by the sound it was making. I got to put another nice dress on it. The wheel I'm using right now is not my first choice for this. It's not that important again because it's not real precision work that I'm doing. But this is aluminum oxide ceramic mix with an open structure 46 grit wheel. And the reason I'm using it is I got to buy some more of the wheels that I prefer to use. They're worn down quite a bit. But this is a good second pit. Actually does a pretty nice job. Doesn't leave quite the finish that I got or I get with the other wheel. And for this type of work, I may have to dress it a little more often. This wheel suited a lot more for your real tough materials, your M2s, your M4s, your twos, stuff that's above Rockwell 60. There, we'll see how she sounds now. That's one of the things that you have to focus on when you're grinding. You use your ears. You're listening to the sound that the wheel makes when it contacts your workpiece. You can look and see the sparks. You can see what's happening there. You can actually feel things. I could feel the vibration. I could tell my wheel was it shifted a little bit. I could feel that right in the hand wheel. So all of those things you work on when you're learning grinding. You start paying attention to all those different areas, what you hear, what you see, and what you feel, and it can tell you what's going on. Okay, what I did, I just tightened the wheel, I redressed it, I made sure everything was tight in the vise over here, but listen to the sound, the difference. When I just touched off, I could tell something wasn't right. And so here's what it should sound like. That's a nice grind sound there. So what I'm going to do is I'm going to plunge in this side. I'm going to go ahead and go about 10 thousandths. Set the digital 0. Come out. I'm going to wind over to this other side. And then we'll make that a nice even 930 on the digital. Sometimes I like to write that stuff down, just in case I forget. And come down about 10. Make both ends. I'm going to back it up about 1,000. What I've done, I plunged on this end, I went down 10. I shifted over to that end, went down 10. I backed things up 1 thou, and I'm going to take 9 thou in one pass coming this way. So just hog this stock out. A lot faster than taking it at 1 thou or so a time, and plus you're not going to generate near the heat. That's just room temperature right there. So now I'll back up to the 930. And we'll come down that last probably 9/10. Come across, take that, and we'll back it off. And just for a cleanup, we'll just take off a few more tenths. Come back to 0. And my tabs look pretty good. I think I'll take a little bit more off this other side. About 10. Well, Adam can come in here and he can get you a close-up of what we just did here now. So what's going to happen now, and we'll probably do this in the next video to grind this pin, just see how much we can get away with. By grinding the step in here, this will go down on the pin in the V-block, like so, and I can set that screw anywhere on here and apply different pressure points. But what's going to happen is the contact of the pin is going to be in the front and the back. And so what it's going to do is going to give me, what's going to happen now is I'm going to have a 3-point contact in the front and I'm going to have a 3-point contact in the back. And I can apply my pressure points anywhere I want on this, and I can change a little bit the accuracy when I indicate these blocks in. The other nice feature with this block, I can always turn it around upside down. This side is flat, there's no step in it. And then I can do a block that's very similar to the one that Robin Renzini did in his video there. So I can use it both ways. And but anyhow, this is the last piece I needed to get set up so that we can make the video on grinding these pins. I'm going to push the limits, and again using that nice Radiac 100 grit wheel, seeing how small of a diameter. I'll probably start at 2 inches, come down to 150 diameter, and we'll start there, and we'll see if this actually works and improves the setup I had. We'll see what we can do with it, and then we'll just keep going a thou at a time until we start having troubles, just to see how far that will go. It blew me away with the job that I've done for a customer. 1.8 distance going down to 150 diameter, and there was no taper in the part. There's no push-off. You can mic it anywhere, and it was good. The finish was great. And so the next video we got, this will show you one of the importance of the proper wheel selection and methods of dressing that wheel to accomplish some difficult jobs like that. So anyhow, that'll be it for this week's video. Hope you enjoyed, and if you want to see the finished product, tune in next week. Hopefully we'll have that next week.